For the first time in the history of modern humanity, the magnetic North Pole jumps to the South Pole and vice versa. Our world will be upside down for some time, and scientists are meticulously trying to find out what the impending magnetic pole jump will mean for the Earth. What is certain is that the development can no longer be stopped. The signs are alarming, and the pole shift may have already begun. Magnetic pole shifts, also known as geomagnetic reversals, have occurred relatively frequently in the history of the Earth, albeit on geological time scales. While this phenomenon is normal for the Earth, it is a rarity for us humans. Magnetic pole reversals probably occur on average every 200,000 to 300,000 years. The last completed pole reversal took place about 780,000 years ago. This reversal, known as the Brunches-Matuyama reversal, occurred an unusually long time ago. It's about time, scientists say. The next pole reversal could have already begun. If the magnetic North Pole jumps to the South Pole and vice versa, the Earth's magnetic field changes dramatically during the transition. It even shows extreme weaknesses for a certain period. During this time, our civilization is exposed to an increased risk of solar storms. Normally, the magnetic field reliably intercepts particle streams from the Sun, but when it weakens, more charged solar particles can penetrate deep into the Earth's atmosphere and possibly cause damage. If we also experience a peak in solar activity, as is currently the case, it could become extremely dangerous. Experts warn that a gigantic solar storm could paralyze our entire modern civilization. A pole shift can last between 1,000 to 10,000 years. It sounds eerie and fascinating at the same time. A pole shift means a complete magnetic reversal of our planet, north becomes south and vice versa. We humans have never consciously experienced this process and do not know what a pole shift will be like. It may feel like nothing changes, or we may experience major disruptions and possibly massive failures of technical equipment. The magnetic field is not absolutely essential for human life, or rather, the effects of Earth's magnetism on humans have hardly been researched. Scientists assume that animals use the magnetic field for orientation, and as mentioned earlier, the field protects us from solar particle streams. These currents wouldn't be a problem for the planet, even if they occur at longer intervals and in concentrated bursts. Again, it is our modern human culture that is at risk due to our dependence on technology. Animals and the planet itself can usually withstand such changes very well. A pole shift is probably not a sudden process, it may take place over 1,000 to 10,000 years. During this time, the magnetic field weakens and becomes more chaotic, with the poles repeatedly shaking or wandering erratically before realigning. Pole jumps occur as a result of changes in the flow patterns of liquid metal in the outer core. This is where the magnetic field is generated by an effect that scientists call the geodynamo. Influenced by thermal convection, Earth's rotation, and possibly other factors from space, the polarity of this geodynamo changes, and with it, the orientation of the poles. Current processes in Earth's magnetic field are alarming. The Earth's magnetic field is currently changing in a remarkable way. Over the last 200 years, the magnetic field has lost about 10% of its strength. There is growing concern as the magnetic field continues to lose strength, and the rate of this decrease seems to be increasing. For some time now, a region with a severely weakened magnetic field has been observed over the South Atlantic. This anomaly is growing daily and could, in the worst case, spread to form a gigantic hole. In this region, satellites and electronic devices are already increasingly exposed to cosmic radiation, and nobody knows where this development will lead. In the north, strange changes have been observed since the 1990s. Since then, the magnetic North Pole has been moving faster and faster. From a few kilometers per year, the rate increased to around 50 to 60 kilometers per year. At the moment, the magnetic North Pole is approaching Siberia. While this still sounds extremely northern, there is a considerable distance between the original North Pole and its current position. Scientists distinguish between several poles. Our Earth has a North Pole, which, measured along the Earth's axis, is almost invariable. Although our planet has experienced axial shifts in its history, these events are less frequent than magnetic reversals. Of course, our globe also has a purely geological North Pole at the top of the northern hemisphere. The magnetic North Pole is determined by the rotation of Earth's magnetic field. Traditionally, all these poles deviate slightly from one another and do not lie synchronously at one point. The magnetic pole is the most active and wanders the most. The magnetic field does not envelop our Earth statically, it circulates and fluctuates. Are we experiencing a supercrown, or is this a false alarm? Some scientists remain skeptical. Are we really facing a pole shift, or is it just fear-mongering? The last pole jump, about 780,000 years ago, was a long time ago, considering that such events occur on average every 200,000 to 300,000 years. Scientists suspect that such long periods without a pole jump are just as normal as cycles of several hundred years. There have been demonstrable phases in Earth's history in which no pole jump occurred for several million years. Researchers refer to such phases as supercrowns, and we could be in the middle of one. During the Cretaceous supercrown, Earth's magnetic field remained stable for about 30 million years. We could currently be in a similar but shorter phase. The trembling of the North Pole may just be a normal fluctuation rather than a sign of an imminent complete reversal. The reasons for an unusually long stability of Earth's magnetic field could be linked to geodynamo mechanisms. The outer core of the Earth might be in a particularly stable phase, with the flow patterns in the liquid iron remaining largely undisturbed. Some researchers convincingly argue that geomagnetic reversals are chaotic and difficult to predict. They claim that long pauses are not unusual, and without further evidence, it is not possible to confidently predict a pole reversal within the next 10,000 years. What would a pole shift mean for our civilization? During a pole shift, Earth's magnetic field will definitely weaken, temporarily reducing our planet's protection from space radiation. This could impact nature and possibly even our bodies in ways that are not yet fully understood. The exact effects of a sharp decline in Earth's magnetic shield have not been sufficiently researched. However, one certainty is that technological systems, such as satellites and communication networks, would be disrupted by increased radiation. In addition to communication failures, power outages could occur. Animals might also be affected. More animals could stray into unfamiliar areas, leading to whales beaching themselves and large flocks of birds getting lost. It is unclear how quickly animals will adapt to the new conditions or whether their internal navigation systems will adjust faster than our technology. Scientists are also debating whether a pole shift would affect weather and climate. We simply do not know what would happen if the magnetic south became the magnetic north and vice versa. What is certain is that a pole shift would pose a considerable challenge for our high-tech society. Scientists are closely monitoring every change to assess potential risks as early as possible. How did Earth's magnetic field come about? It is actually a miracle. The Earth's magnetic field enables our planet to sustain an atmosphere, making life possible. Planets without a magnetic field, such as Mars, lose their atmosphere if they ever had one. The geodynamo inside our planet is therefore a true stroke of luck. Inside the Earth, the planet's rotation causes electrically conductive liquid metal to move, generating magnetic forces. The Earth's core consists of a solid inner core and a liquid outer core. Extreme heat from the inner core melts iron and nickel in the outer core, creating convection currents similar to boiling water. The movement of this conductive liquid iron generates electrical currents, which in turn generate a magnetic field. Earth's rotation forces these currents into spiral patterns, a phenomenon known as the Coriolis effect. Once formed, the magnetic field strengthens these motions, creating a stable cycle that maintains the geodynamo. This global magnetic field surrounds the Earth like a giant bar magnet, forming the magnetic north and south poles. Despite being scientifically understood, Earth's magnetic field remains an extraordinary phenomenon. Without it, our world would not be what it is today. Click the subscribe button now to be the first to see all our new videos.